everybody. So this video is dedicated to my findings for this ball bounce project. The main premise of the project was to find a series that represents the total vertical distance a ball travels after being dropped from a known height, which in my case was 50.1535 inches, which is a little bit over a meter. So the first thing I was asked to do was find the sequence, or A of n. But even before that, I had to find out what kind of series this could possibly be, which led me to a geometric series, because they usually represent something that's declining fairly rapidly, which is exactly what the ball's bounce height is doing after each consecutive bounce. Um, just as a reminder, geometric series have the form the sum of n equals 1 to infinity of ar times n minus 1. So A in this case was the drop height, which was 50.1535 inches, and R was the ratio of the first bounce height to the drop height. For my experiment, I found that the first bounce height was 32.9157, and when you divide that by the drop height, you get about 0.656299. So our sequence is 50.1535 times 0.656299 to the n minus 1, which is right here. The second thing I had to do was find S of n, which is equal to the sum of n equals 1 to infinity of our sequence. And we can actually find out what the sum is with the equation a over 1 minus r. And this equation is equal to 50.1535 over 1 minus 0.656299, which is about 145.92, which gives us our total vertical distance that this ball travels. Now the last thing I had to do was find the limit as n approaches infinity of S of n. In a way, we're also proving that the series is convergent because, as we can see here, the limit goes to 0. And when the limit goes to 0, that's a good indicator that your series is convergent or can be convergent, which in this case it is convergent because we saw that it's 145.92 inches, which is what it converges to. Now I'm going to show you guys a little chart that I made. It's the terms of the series versus my measurements. I just wanted to make a quick little note that my measurements and the terms of the series won't always match perfectly, and that's because of my own human error and the fact that the series represents an ideal situation where there is no human error and there's no outside factors affecting the ball's bounce height. And those factors could be like the surface it's bouncing on, wind, things like that. So the first three terms are about pretty much perfect. The third one, not so much. It's off by about 1. Fourth is where we're seeing some discrepancy. It's about 2 off here. 5 is pretty significant. That's probably my own human error there. 6, it's pretty off. 7, it starts to get closer. 8, it's closer. 9, there's hardly any discrepancy. And as we continue, as we go to infinity, the difference will be very, practically unnoticeable. So I think that's about it. Thank you guys for watching, and I'll see you next time.